Blackness. Silence. Then, a heartbeat, slow, heavy, unfamiliar. A faint blue glow emerges from the void earth, but something feels wrong. The oceans stretch wider, the continents feel heavier. The horizon curves differently. You try to stand, but your body resists. Your legs tremble. Every movement feels like lifting stone, because this is not the earth you know. This is a world just 10% larger. And that small change changes everything. What if Earth's diameter increased by just 10%, not double, not extreme, just slightly bigger. At first glance, it sounds harmless, even insignificant. But planets are delicate systems. A small shift in size rewrites gravity, atmosphere, life itself. This isn't just a bigger Earth. It's a completely different world. Tonight, we explore what would really happen if Earth grew by just 10%. Let's begin with the most important consequence: gravity. Gravity depends on mass and radius. If Earth becomes 10% larger in diameter, its volume and therefore its mass would increase dramatically. Volume doesn't scale linearly. It scales with the cube. So a 10% increase in size leads to roughly a 33% increase in volume. Assuming similar composition, Earth's mass would also increase by about 33%. Now combine that with a larger radius. The result, surface gravity wouldn't increase by 33%, but it would still rise significantly by about 20% more than today. That means every step you take, every breath you draw, every heartbeat would happen under heavier force. You wouldn't weigh 70 kilograms anymore. You'd feel like 84, and your body would notice. At first, you might adapt. You could still walk, still move, but everything would feel harder. Climbing stairs becomes exhausting. Running becomes nearly impossible. Jumping, forget it. Athletes would struggle. Records would shrink. Human performance would decline. And over generations, evolution would respond. Humans would likely become shorter. Stockir. Denser bones. Stronger muscles. Because tall, slender bodies collapse under higher gravity. The human form itself would change. But not everything adapts easily. The heart, for example, must pump blood against gravity. With increased force pulling downward, circulation becomes harder. Your heart works more. Your blood pressure rises. Over time, this could lead to widespread cardiovascular stress. Even breathing changes. The lungs must expand against greater force. Air feels heavier. Breathing becomes labor. Life continues, but it's more difficult. Every moment is heavier. Now shift your gaze upward. The sky itself would change. A stronger gravity means the atmosphere is pulled closer to the planet. Compressed. Denser. Thicker. At sea level, air pressure would increase significantly. Breathing would feel different, not just harder, but richer. More oxygen per breath. At first, that might seem beneficial, but too much oxygen over long periods can be harmful. It accelerates oxidation. Aging. Even fire becomes more dangerous. Because higher oxygen levels make combustion easier, fires burn hotter, spread faster, more violently. Now imagine entire ecosystems under this dense atmosphere. Storms would intensify. Clouds would form lower and thicker. Weather systems would carry more energy. Hurricanes could become more destructive. Winds heavier. Rainfall more intense. The sky itself becomes a more dangerous place. Earth's oceans would deepen. Not necessarily because more water appears, but because gravity reshapes how water distributes. Stronger gravity pulls oceans tighter against the planet. Shorelines shift. Coastal regions change. Some land disappears beneath deeper seas. Waves behave differently too. They carry more energy. Crashes hit harder. Erosion accelerates. And the water cycle intensifies. More evaporation, more condensation, more rain. Floods become more frequent. Rivers swell faster. The entire hydrological system becomes more extreme. Now look beneath your feet. Earth's crust. Tectonic plates. Volcanoes. With greater mass comes greater internal pressure. The mantle becomes more compressed. Heat builds differently. Tectonic activity could increase. More earthquakes. More volcanic eruptions. Mountains, however, tell a different story. Higher gravity limits how tall mountains can grow. Rock can only support so much weight before collapsing. So despite increased tectonic activity, mountains would actually be shorter. Flatter. The Himalayas as we know them might never reach their current heights. The landscape becomes more compressed, more subdued, but more unstable. Life evolves under pressure. Literally, Large animals would struggle. Their weight increases dramatically. Skeletons must support more mass. Movement becomes inefficient. Over time, evolution favors smaller, sturdier creatures. Giant animals like elephants might shrink. Birds face an even greater challenge. Flight becomes extremely difficult. Gravity pulls harder. Lift becomes harder to generate. Wings must be stronger. Larger. Or flight disappears entirely. A world with fewer flying species. Perhaps none at all. Forests would change too. Trees can only grow so tall before gravity causes structural failure. So forests become shorter. Denser. More compact. Everything in nature adjusts to survive. Underweight. Our current Earth is balanced. Gravity, atmosphere, life all exist in a delicate equilibrium. A 10% increase disrupts that balance, not enough to destroy the planet, but enough to reshape it entirely. Compared to our Earth, humans are weaker. The atmosphere is heavier. Weather is more violent. Oceans are deeper. Mountains are shorter. Life is smaller. It's still Earth. But it feels alien. Human civilization would also evolve differently. Transportation becomes harder. Planes require more energy to achieve lift. Air travel becomes expensive. Limited. Space travel, even more difficult. Escape velocity increases. Rockets must be stronger. Fuel requirements skyrocket. Reaching orbit becomes a massive challenge. Space exploration slows, or never truly begins. Architecture changes too. Buildings must support greater weight. Structures become shorter, thicker, more reinforced. Skyscrapers, rare. Maybe impossible at current scales. Even simple machines require more energy. Everything costs more effort. Progress slows, but humanity adapts, because it always does. This scenario reveals something deeper. Planetary habitability is fragile. Life depends on precise conditions. Too much gravity, too little, too thick an atmosphere, too thin. Each factor shapes evolution, civilization, and survival. A 10% change may sound small, but in planetary terms, it's massive. It redraws the boundaries of life itself. Now imagine standing once more on this heavier Earth, the sky pressing down, the ground pulling harder. Your body struggling against invisible force. And yet, life persists. It adapts. It reshapes itself to survive. Because life doesn't require perfection. It requires possibility. But here's the question. If just a 10% increase can transform Earth so dramatically, how different could life be on planets only slightly unlike our own? And what kinds of worlds are still out there waiting to be discovered? The heartbeat returns. Slower. Heavier. Then silence.